In this lesson, Unit 1, Lesson 6, Graphing Relations, we are going to create a table of values from a linear relation. That means that every graph that we're going to get, it's going to form a line. We're going to graph the table of values and analyze the graph to draw conclusions and solve problems. And in the process, we actually have to evaluate expressions given the value of variables. So that's kind of the review part. Okay, so in the math lab, we have a graph on the right-hand side, and it says, A, what does this graph show? Well, it kind of shows that we are talking about the number of jelly beans in the bag. Okay. What do the numbers along the horizontal axis show? Horizontal means left to right, or like looking at the horizon. So that would be this line right there. So it would represent the number of bags. The number of bags. Okay, and I'm just going to erase that so we don't get confused. It says, what do the numbers along the vertical axis show? So that is up and down. Vertical is up and down. So that is the number of jelly beans. It says, how many jelly beans does one grid square on the vertical axis represent? Okay, well, if I go up 1, if I go up 2, I go 30. So if 2 grid squares equals 30 jelly beans, then 1 grid square has to equal to 15. So what we're going to do is we're going to use this purple dot, or this data point, and we're going to call that point 260. And we're going to answer, so 2 comma 60, so that means that we went 2 over and 60 up. And we're going to use that point in order to answer the rest of the questions. It says, what does this point tell us about the number of jelly beans? Well, what I can see is that in 2 bags, there are 60 jelly beans. Whoops, I can't type. There. So if there's 60 jelly beans in 2 bags, then there must be 30 jelly beans in 1 bag. And why do you think so? Well, you could do that just by, doing the math in your head. There's 60 in 2, there's 30 in 1. Or what we could do is we can go over to 1 bag and up to 30. So we could do some math, or we can use the graph. How would we write a relation to represent this information? So what we're going to do is that there's the number, whoops, I'm going to just go and type. It's easier for me to type. Number of bags. Whoops. And it's compared to the number of jelly beans. Remember, a relation compares 2 sets of data. So in this case, we have the number of bags to the number of jelly beans. So if I want to write a relation, instead of having to write that out, if I call this n, this would represent 30n, because there's 30 in each bag. How can we use the graph to find out how many jelly beans are in 5 bags? Well, what we would have to do is we can use a pattern. We would go 2 over and 2 up, noticing that it's always 2 over and 2 up. So we would actually have to extend the graph 2 over and 2 up. We would actually have to extend it. So we would find that 5 would be 20, another 30 from 120, so 150. Okay? We would actually have to extend the graph. And when we extend the graph, we're going to come up with this word again. It's called extrapolation. Okay, so we're going to be using that word again. So whenever we actually have to extend that graph in order to get the information we need to answer the question, it's called extrapolation. Using a piece of information like within the graph that's already provided to us is called interpolation. We're going to be talking about those later on. So in order to get all the information we need from a graph, we need 4 things. We need a title. If we don't have a title, then we don't know what we're graphing. It's just a whole bunch of dots. What else do we need? Well, we need to label both horizontal and vertical axes, and with units if needed. Okay, so if you're talking about time, you need to put the units of days, seconds, hours. If you're talking about length of a football field, you need to say you're measuring it in centimeters, inches, meters, kilometers. So whenever there's units, whenever the units really determine what you're plotting, the data that you're plotting, you have to put that in your label. The next thing we did was we scaled each axes with appropriate numbers. Okay, so we're not going to, if we have data between 0 and 1,000, we're not going to scale our axes by 1. We're going to scale it by hundreds. So each of those little grids, square grids, would be worth 100. Okay, so we have to just really use our appropriate numbers when we graph. And then, of course, the last thing we need on the graph are the data points. So we need to know what the information is or where the information is. Okay, so those are the 4 main things we need to make sure that we draw graphs properly. So let's continue on here. So we have the cost of N CDs in dollars is 12N. Okay, so let's talk. Remember how I always gave you, here's our relation. And remember how I always gave you the values of N? Well, sometimes I don't give you the values of N. Sometimes you have to kind of use your common sense to figure out what are appropriate numbers. Now, does it make sense for you to buy -3 CDs? No. So we can buy 0 CDs, we can buy 1 CD, we can buy 2, 3, 4, and 5. So we always start with the smallest amount that we can buy, which is 0. We can walk into a store, look around, and then walk out. And we spent $0. If we go into a store and we buy 1 CD, then we spent $12. And if we follow the pattern, you can use your calculator if you choose to in order to find those numbers, or you can continuously add 12. Okay, so the cost of 1 CD is $12. How did you find the cost of 2 CDs? Well, there's 2 ways. You can go 2 times 12. You can use the relation. Or you could just add 12 from your table. So what patterns do you see in the table? Well, remember, we can talk about input-output patterns, or we can talk about output-output patterns. So we have to multiply. Let's talk about the input-output. If we multiply the input by 12, we will get the output. And what we can do, if we add 12 to an output, then we will get the next output. So those are the 2 patterns that's review. We've done those before. We've talked about patterns that go this way, and that's the multiplying by 12, like the input to output, 3 times 12, 4 times 12, 5 times 12. Or we can look at output to output. So if you notice, all I'm really doing is adding 12 each time. So those are your 2 patterns. Now let's graph the data. So first of all, we have to talk about a title. So cost of CDs bought. Okay, so that's a good title. Okay, label the axes. So we need to put number of CDs down here. And there are no units because the number of CDs don't have a unit. But amounts spent, we need to put in dollars because we need to put the units for money. Okay, so I'm just going to flip that around so that I can do it like this so I can show you guys there. Okay, scale the axes properly. So what I'm going to do is I'm going to actually draw in where my axes are first. And I'm going to start at that bottom left corner. And I'm going to show you that my axes do continue on. So I'm going to put an arrow on them because they do continue on. You can buy 100 CDs if you were that rich, okay, in one shot. So now what we have to do is we actually have to scale. Now we have to look at the numbers. Okay, so I just went back to my data chart and it's 0 to 5 for CDs. So I can go 1, 2, 3, 4, 5, 6. That works. And again, if you did every one instead of going every second grid, that's fine. You can, but your data would be really, really close together. I like data that's spread out. So I'm going to go every second square as one CD. So now we have to go back here and look at, well, my cost is between 0 and 60. Okay, well, let's see. If I go 10, 10, 20, 30, 40, 50, 60. That's what I would probably do. 10, 20, 30, 40, 50, 60, and 70. Okay. Again, if you want to go up by 5s, that's fine. If you want to go up by 12s, that's fine. That was the first thing. Usually when you scale, you're going up by 1s, you're going up by 2s, 5s, 10s, 20s, 100s. Like it's a nice number. Okay, now I'm going to flip back and forth because now I have to do the graph the points. So 0, 0 is right here. Okay, let me see if I can actually get a nice little, I'm going to do nice data points for you. I'm going to fill it in with red. Okay. Okay, so here's 0, 0. Then my next one was 1 CD was $12, so about right there. 2 CDs was $12, so just under half. 3 CDs was 36, so just over a half. Whoops, yeah, is that right? Did I miss one? Does that look about right? Yep. Okay. 4 CDs was 48, so just about 50. And look, they're forming a line. And 5 was 60. Look at that. A perfect line. So how did you find the cost of 5 CDs? Well, what I did was I used the relation. I went 5 times 12 to give me $60. Okay. How could you use the graph to get the information? Well, once you have the graph, all you have to do is go over to 5 and up to the data point. So go over to 5 CDs and then go up to $60. So you can use the graph in order to get the data or the information you need. So how would you describe this graph? Okay, well, it rises, it increases to the right. So it goes up to the right, which was great. It's linear, which means it forms a line. And you know what? I'm going to even put in there it's discrete data. And I know that you did this discrete data in grade 6. Discrete data is, does it make sense that, can you go into the store and buy half a CD? Well, no. We're not talking about iTunes where you can buy half a CD or whatever. We're actually talking about physically going into a store and buying a CD. So it doesn't make any sense to have all the dots in between. It's 1, it's 2, it's 3. It's like, you can't say, I want half a person to fit into this car. It just doesn't make any sense. So when that happens, that's called discrete data. Okay? So you can talk about that. It rises to the right. It's discrete because the points in between don't make any sense, and it's linear. It does. If I was to connect these dots, it would form a straight line. Okay, So how do you get from one point to the next point? Well, let's take a look. How did I get from one point to the other point? Well, for every one CD, I went up 12. For every one CD, so for every one CD, the vertical axis goes up by 12. And so how could you use the graph to find the cost of 12 CDs? Well, I wouldn't use the graph. I would definitely use the relation. But again, you would have to extrapolate. So extending the graph and using the pattern that we found in question I. How can you use the graph to find how many CDs you could buy with $72? Well, you can go 60 and then up 12 and then over to see that it's 6 CDs. And that's chances are what you would do. So you would actually go to 72, which is about right here. And if I was to draw a line through here, look, it actually falls right on 6. It's almost bang on. Okay, so it would actually be 6. Okay? But I'm going to delete those because we would not connect those lines. Okay, so that's how we would use the graph to answer or to find. So when we're graphing, the input is always plotted on the horizontal axis. If the input is on the horizontal, then the output has to be on the vertical. When the points can be connected by a straight line, we say that the graph is a linear graph. Okay, it's a linear relation, it's a linear graph, it forms a line. I'm going to let you guys do this one on your own. Please come and check with me to see if you've done it correctly. And your homework was page 33, number 1, 2, 4, 5, and 6. Remember, when you draw a graph, you need to include a title, label on both axes, scale the axes appropriately with the right numbers, and put in your data points. Your input is always on the horizontal. Your output is always on the vertical axis. And then if the data point looks like it can be connected with a line, then that relation is called a linear relation. I sure hope this helps out.